So first approach to make all possible subset will always be recursion, because you have to develop or get all possible subset. So you can easily do technique of take or not take. For example, this is array, you have to position, so you have choice to take the first element and you have choice to not take. If you take the element, you'll be having 1. If you don't take, we won't be having anything. There which will be empty subset. Then from here we have possibility to take 2 in both. So if I take 2 or not take, if I take, it will be 1 comma 2, and if I don't take, it will be just 1. And here same, I have possibility to take 2 or not include. So if I include it, so it will be 2. If I don't include, it will be just empty. As you can see, it will generate all possible subset for the given array. Now the second approach, that is how to solve using less space or without a constant space, big O of 1. As in recursion, it is taking big O of n recursion stack space. Up to do that, it was not easy. I have also watched videos and all, but the only way I can tell you the intuition is if you try different array, like for 1 2, all possible subset will be this, no element, 1 2 1 2. So there are 4 subsets. If you have 1 2 3 elements, you'll be having these many subsets, which will be 8. Or if you have just single element, the possible subsets will be empty set of 1, so which will be 2. And if we look closely, they are powered to the 2. So for this, you have 2 की power 2 is equals to 4, where 2 is number of elements. Here 2 to the power 3 is equals to 8, where 3 is number of element. And same with here, 2 to the power 1, which will be 2, which is equals to number of elements, you can see. So the thing that we understood is the number of subset will always be equals to 2 to the power number of elements. So what we can do, we can use bit manipulation. It is not easy, I am telling you. I also couldn't understand in first go, so it took me a lot of time. So I'll explain using simple example. Like this is your array and you have to generate all this possible subset. So you'll get a maximum possible subset or maximum possible number of subset will be 2 to the power n, or you can use to power function or anything, 2 to the power n, where n is size, so which will give you 4. Okay, so here what you'll do, you'll create a 2D array. You'll create a 2D array, I'll explain, which will be size of maximum possible subsets, so it will be 4 1 2 3 4. Okay, and then what you'll do, using bit manipulation, for example, let me tell you. So maximum you will be having 4 subsets. So for each subset you'll pick these elements. Of how you'll pick using bits. For example, m, you have m, you'll take a variable m which will vary from 0 to 0 to 3, and you'll take a variable I or j, you can say, which will vary from 0 to size -1, यानी कि 0 to 1, 0 to 1. Yes. Basically what we are doing, we are checking if to take element or not using bits. If I'll explain you, for example, m will vary from 0 to, m will vary from 0 to 3, I will vary from 0 to 1. What we'll do, we'll use 2 for loops. If m is 0, which will represent using this, and I equals to 0, and we'll do AND of these two. Okay, we'll use 1 left shift of I, Okay, so it will be this. So AND operation will be 0 0 0. Okay, which is not equals to 1. If it is not 1, we won't take any element, empty subset. Then if m equals to 1, so it will be 0 0 1. I equals to 0, then it will be 0 0 1. It will be 0 0. AND of these two will be 1. So what we will do, we will insert the value at position m, and what we will insert, we will insert this element. So we are checking which element to insert. Like we want to insert element at index 1 or index 2 or index 3, or if these two both are 1, then we have to insert both element. So I'll explain you just this key. This is 1. So when our I equals to 0, so we'll insert the ith element, any 0 element. So it will be 1 here. Then what we'll do, m equals to 1 and I equals to, I was 0, then I equals to 1 will be there. So this will shift by 1 digit. Okay. Then we'll do AND. Then nothing will be there, so we won't insert anything in first index. Then what we'll do, then we'll go m equals to 2, so which will be represented by this I 0, which will be 0 0 1. Then it will be nothing. Okay. Then I equals to 1, which will be represented by this. Okay, so which will be, we'll be inserting second index element from this array, or you can say we will insert the element the element at ith of the ith index at this m position. So m position will insert the ith element, which will be 2. And next, for m equals to 3, we will insert, for 3 we'll write it like this, up I equals to 0, and we have I equals to 1. So for 0, we are using I left shift, one left shift I. So one left shift of 0, which will be this, which will give you this. So we will insert 0th element of this array on the third position. So you'll insert 1. Then now what you will do, you will left shift 1 by I value. So which will be this, which will give you, so this is 1 greater than 0. So what you'll do, you insert the first element or the ith element, for the generalized term, ith element of this array at the position m. So you'll insert 2. So if I remove everything else, you can see that these two are same. So this was generated using recursion, this was generated using bit manipulation, this is using big O of 1 stack space, using big O of n recursion stack space. But this is time complexity is equals to big O of n square. Time complexity was big O of n. So I know this is not very intuitive approach. Recursion is much better, but if you want to optimize your solution, this is much better. Like and subscribe to my YouTube channel. Bye bye.
You gon' see success in me. You ain't seen the rest of me. I just wanna be the best at what